All right, so today we're going to be talking about Charles's law. It is going to be our second gas law, and it actually relates our volumes and our temperatures. So if you think about our molecules, they're getting a lot more energy in heat energy, and they're going to want to be moving around a lot more, and so they're going to need more volume. They're going to spread out farther, okay? So there's a directly proportional relationship. So it's a directly proportional relationship, and what that basically means is that if you increase the temperature, you're going to increase the volume. If you decrease the temperature, decrease the volume. What is temperature? So temperature is going to be a measurement of heat energy, and we are going to be using the unit of Kelvin for this. You must use Kelvin. You must convert to Kelvin when we are doing these practice problems. The way that we do that is right here. Our unit conversion is as follows. Take your degrees Celsius, add 273. That's what our Kelvin is going to be. So 0 degrees Celsius, which is our standard temperature, is going to be 273 Kelvin. Okay? So we sometimes operate at standard temperature and pressure, 1 atm, 273 Kelvin. First example. All right. So the temperature of a 3.5 liters of gas is changed from 20 degrees to 45 degrees. What's the new volume? So we have our starting volume right there. That's our V1. And then we've got two temperatures. But these need to be converted into Kelvin first. So first we're going to do 20 plus 273. And that's going to give us 293 Kelvin. Okay. And then we're going to do 45 plus 273. And that is going to give us 318 Kelvin. Okay, and that's actually going to be our T2. All right, this is our T1. And right in the problem, I circled our information and we're labeling it. Okay, so now we're going to plug it in. Our V1 is 3.5 liters over our initial temperature, which is going to be 293 Kelvin, equals our second volume, which we do not know, that's what we're looking for, over our second temperature, which is 318 Kelvin, which we do know. So now we can do this math out. We're all set, okay? This is our equation set up, ready to rock and roll. My suggestion is that you simplify this half of the equation first, and then you can multiply by 318 on both sides. When you do that, you should get a volume of 3.79 liters. All right, and that is our first example. For our second example, we're actually going to be given both volumes, and we're going to find one of the temperatures. This is going to be a little bit more tricky just because you have to use the cross-multiplying strategy from math class. So we have 2.7 liters of a gas, so that's a volume, at standard temperature and pressure. So we know what standard temperature. Okay, great. So that's going to be 273 Kelvin. And those are our initial conditions, V1 and T1. The gas is going to be compressed to 1.4 liters, so that's my V2. What is the temperature? So now I'm going to plug everything in and solve. So I've got 2.7 liters over standard temperature, 273 Kelvin, equals volume 2, 1.4 liters, all over T2, which is what we're looking for. Okay, so you'll notice that this math is a little bit harder to do because we've got a variable in the denominator. So what we can do is we can cross multiply. All right, so we are going to multiply the things that are in our corners. So I've got 2.7 times T2, so 2.7 T2 equals 273 times 1.4. Okay, so you can simplify, and 273 times 1.4 is going to be 382.2, and then you're going to divide by 2.7 on both sides. Okay, so that eliminates out, and we get our value of 141.56. And we're temperature, so that means our unit is Kelvin. And that is it. Awesome.